Hi everybody, welcome to our bootcamp presentation. My name is Felipe Leme and together with my coworkers Jan and Mayank, we all work on the Android Automotive Framework team. We're going to be talking about a multi-user on Android 11 on Automotive OS. And before we talk about this, what's going on Android 11 itself, we want to give a quick overview of what is multi-user on Android. So if we look back on history, when Android was first introduced, it was only available for phones, and there was no such concept as multi-user because there was just one human user using the phone. Then a few years later, with the advent of tablets around 2011, I think, Android introduced this concept of users, or Android users, which basically represents a human using the device or using the phone or tablet at the time. So these users, they have some characteristics, like they have a unique user ID in the system, and each user has its own user data, which is encrypted on the data on the disk and they isolate from other users. That data has to be decrypted before it can be used by the system, and typically the user might set up a credential like a PIN or password. So when the data is protected by a credential, then the user has to type, the human user has to type those credentials on screen so the data can be unlocked from the device and then could be used by the system. There is also this concept of foreground and background users. So there is always going to be a foreground user, just one foreground user running the system, and that's the user, that's the Android user that's interact with the UI. But there could be some users running on the background as well. In fact, when the Android boots, it boots on what we call system user, which is user 0, and that's going to be the foreground users. Now, let's say the human wants to change it to a different user. They have to select that user on the UI, and then the user 0 would go to the background, and the new user would be switched to the foreground. So this is what we call switching user, which is a concept we're going to be talking about. Another concept that you all often see on code is current user. So current user basically means the current foreground user. Now these are the general characteristics of multi-user. These are the same for Android, or for phones, or car, or TVs, for all form factors. But there are some characteristics that are different on phone and on automotive. So first one, phone by default only has system user, the user ID with system with user ID 0. Sorry, user with the user with ID 0, which is the system user. So when you buy a new phone, it starts as user 0, and eventually you as a human user can add more users. These are called secondary users. Automotive is slightly different because the system user is what we call a headless system user, meaning it's going to be running on the background, but it's not going to be the user that has the UI. So the real user is going to be a secondary user, typically user 10 or 20, and that's a user that's created by a car. So when we boot the phone for the first time, Android itself starts as user 0, but then when the car service runs, you will create the secondary user and will switch to that user. So when you run the setup wizard on automotive, that's going to be running on the secondary user, not on user 0. Uh, there's also some other characteristics that are very specific of cars. One that is what we call UX safety restrictions. So there might be some operations that you cannot do on your phone because the car is moving. And for example, you could not lock the screen because maybe the driver is navigating using Google Maps. And also, a lot of cars, they might have their own concept of users. So there's, especially on high-end trims, they might have what a lot of manufacturers call memory set, where you can set up some characteristics of some ECUs, like the seat position, mirror position, and you would want to associate that with some specific drivers. So this is a characteristic that only happens on automotive, because on automotive there are a lot of components running at the same time, while on a phone it's pretty much just one chip, just one device. This characteristic make it a little bit harder for us platform to support multi-users because there is there's some this difference make it harder to run some other systems on Android or just them to run on automotive. For example, there's a lot of systems like location or Bluetooth. They might not be aware of this concept of headless user and always thinking that the main user is user 0. And also there's some performance implications as well, because every time you're switching a user, it doesn't matter if it's on Android, on phone, or automotive, it takes a while to switch the users because you have to start, you have to unlock the user data. My package manager might need to parse all the packages available to that user, and then other services might do some other stuff. So there's always some delay starting user, and that could even affect boot in case of automotive because now you're starting two users, not just one. So how do we address these challenges? Well, we, the Android Automotive OS platform, we keep improving on each release. So we are always doing something for multi-user based either on our internal tests and performance analysis or based on partners' feedback. So just to give two examples, on Android 10 or on Android Q, we added this concept of headless system users. We also added a class called Car User Manager Helper that makes it easier to use the existing user manager APIs. And we add some new features to help the performance as well. So I'm not going to spoil because this is going to be talking about in a few slides later on. And on Android 11, we also add new features that is what we're going to talk next. So first, on user 11, we added the new user hall and manager. Let's start with the user hall, that they are kind of integrated. So this user hall, when we say user hall, it's a way for the OEM to interact with the Android multi-user workflow. So let's say that case where each user, each driver has their own seats adjustment or mirror adjustments. We want to make it easier for the OEM to change that when the user changes on Android. So we're going to be providing these capabilities through a hall, which the OEM has to implement, and some new APIs that the system apps or bundle apps like a settings has to call. We'll also be adding some new features like a key fob assignment and easier way to listen to user switch lifecycle events. So let's start with the user hall itself. When I say user hall, it might sound like you have to implement a new hall, but actually that was our initial idea. But we thought that would be too much work for the OEM, so we decided to instead add the new properties to the existing vehicle hall. Now, this so-called user hall, it's more like a request response protocol where the car services need to ask for hall for something and the hall has to respond. So we have some well-defined objects for this protocol, but they have to be implemented to the existing vehicle hall, which means car service is going to be setting some properties on hall, and then the hall is going to respond by sending a property change event with the response. Now, because this, even though we have some what I call rich objects that define this protocol, they still have to be flattened into the vehicle property value. So we need to convert that as we'll see next. Finally, one key design decision we made was that every time we call user hall, we pass the current status or current state of all users on the device, on the Android. So we're going to tell hall what's the current user, the current foreground user, what are these flags, and then what are all the other available users. So that way, the hall can synchronize its internal state with Android's state. Finally, since we're going to be implementing this request response in an async way, by async, I mean we set a property and later we're going to get a response, a property change event. So we're going to be using some request ID to correlate the request to the response. So every time the user hall receives a set property, which is a request, when they send a property change event, they have to use the same request ID. So how do you as a OEM implement this user hall? So first, there's two steps you need to do. First, you need to set a system property called Android call user hall enabled. So you have to set that to true. So car service knows that it should be sending this property change requests to user hall. And then you have to implement four properties, which we're gonna talk about each of them later. And optionally, there's a fifth property that you can implement, but that one is optional. You can either implement that together with the other four properties, or even if you don't support user hall, you can still implement that property and use the API that uses it. So let's start with initial user info. This property is called when the Android starts. And the idea is we need to remember when Android starts, it starts as user 0. So we want to ask which user should be run, like how can we switch from user 0 to the real user. So this is going to be called on multiple steps. Like we're going to be calling that every time there is a cold boot, meaning the device was booted from scratch, like the whole system was turned off. So that's what we call cold boot. And there's also two special types of cold boot, which is the first boot after the device, the very first boot, or every boot after the Android was factory set, and also at the first boot after an OTA, we're gonna call as well. Then most OEMs might be implementing suspend to run, which means when you turn off the car, the system is still running, but it's on a low power consumption state where the system is safe to run, and when the car turns on again, it's resumed. So we're going to be calling initial user info as well in this case. So the main difference is we're going to be passing an attribute on the request to tell where this request is coming from. So if you're familiar, if you're using Android Q already on the Android 10, we provide a similar mechanism through the boot user override ID property, but this new mechanism is more powerful. And in fact, if you're using system HAL, we're going to be ignoring that property. So once the user HAL receives that request, it has to respond, it has to tell Android what to do. And they have three options. One is it could say, okay, I just want to use the default behavior defined by Android, which roughly speaking means just switch to the last user that was using the car or create a new user, which is the first boot. Or you can tell switch to a specific user where OEM would pass the user ID of that user, and that's in fact that's the same mechanism that was provided before by the system property. But now there is a third option which is more powerful, where the OEM can tell us we need to, by us I mean Android system, they can tell which user to be created. So they can tell what's the name of the user, what flag is, if it is admin or guest, and even the locale, like, oh, this is going to be a English from US or Spanish, etc. Notice that whatever is returned by OEM, Android will try to comply, but it's not guaranteed, because if it might fail, in which case it will fall back to the default behavior. So for example, the user hall might say, I want to create a new user, but the maximum number of users was reached already, so that would fail. In that case, we would fall back to switch into the previous user. So let's see an example of how this works on the request and response. So first, the car service will make this request. So the request is defined by initial user info request, but we need to flatten that into a vehicle proper value, which is the standard property from vehicle hall. And the way we do that is by adding the initial user info request attributes into the int32 values and string values, but in this case, just the int32 values. So the first integer will be the request ID. In this case, is 1 because it's the first request. But the value doesn't really matter for the OEM because this is a value that's dynamically generated by car service. Then we have gonna tell where this what type of initial user request is this. Is it the first boot or resume or code boot? So in this case, since we're just starting, turn on the car for the first time, it's going to be first boot. And next we pass what's the current user and its flag. So there's remember when Android boots is running user 0, so the ID is going to be 0, and the flag is going to be 1, which means system. Notice that this flag is a flag defined by HAL. It's not the existing user info flags from Android. Next, we're going to tell what are the existing users. So we're going to say how many users exist and what are the ID and flags. In this case, there's just one, so we're going to pass the user ID 0 and flags 1. Then the HAL has to respond. So let's say we want to create an initial user. It's going to be an admin user called car owner, and the locale is going to be in English US. So they have to send a property change event with the same property and the same request ID, in this case 1. Then the next two values are going to be something specifically from the initial user info response. The first is going to tell what action it is, and there's a num, and create is value 2. And then they have to pass the user ID and flags. In this case, the user ID doesn't matter because it's going to be created by Android, and the flags is going to be 8 because we are setting that's admin. Finally, you have to tell what are going to be the strings. In this case, there are two strings, so we need to use a special separator. It's going to be this double pipe. So we're going to pass the local double pipe, the name of the user. So that's it for initial user. Now the next one, which I would say is the more important one, is the switch user. So the switch user, it's called when the Android foreground user is switching. So when let's say you start the car as user 10, and the user might go to the button to say, oh, I'm on a switch to user to my wife or something. That they select a different user, and the Android has to switch this user. So traditionally, this is done through Activity Manager. There's an API called Activity Manager.update API. Sorry, switch user, and so when that API is called, we're going to be running what we call a legacy workflow. But then we are also adding a more powerful API, which I call the modern workflow. By modern, I mean it's an API that fully supports the car user case. And that API, the workflow has to be started by car user manager. And finally, we're also going to be allow the hall itself to request a user switch. So I'll tell why and show an example soon. So let's start with the modern workflow. So this modern workflow, I like to compare that to a distributed transaction that uses a two-phase commit. So if you're familiar with distributed transactions, you need to do something that requires changing two distinct or distributed database. So we want to make sure that this transaction is committed on both, or otherwise the whole transaction is failed or rolled back. So the way we do, because how we think the how is more important, the how has to define whether this can be switched or not. We're going to be first calling the how to ask if the user can be switched. And if the user can be switched, then we're going to be switch on Android. Once Android confirms that it can be switched, that means the whole transaction succeeded. Then we're going to confirm to how we're going to send another message to the user how saying, hey, the user was switched, so now you can commit your transaction. So that at that point, how could safely move the seats and change the mirror adjustments because they know that the user was changed. Otherwise, if it fails, we're going to tell them, okay, the Android user for some reason couldn't be switched, so forget about this request and don't change anything. Also notice that this is a new API, this is a new workflow, and it has to be called by Car User Manager. But Car Settings is already doing that, so if you have your own custom settings API, I would recommend you look on how Car Settings does, and then you can follow up and change your code appropriately. Let's take a look on, before we take a look on the low level calls, I have this class diagram that represents what's going on behind the scene. So the real names are slightly different, but the idea is the same. So you're going to have a UI, like a settings, that's going to be called Car User Manager. And these new APIs are going to be sync, meaning they're going to ask the car manager to switch user, and later they will get the result. Then this call goes all the way through the Hall, where we send a switch user request, and then Hall has to respond with the status. Let's say they say, okay, the user can be switched. And at that point, we're going to call Activity Manager. And once Activity Manager return, then we send the post switch request to user Hall. And at that point, Hall, they can move, call the ECUs that change seats and mirrors, etc. So let's take a look on the objects or the properties or the calls that are made from car service to user hall and vice versa. So the request, the switch user there's going to be a switch user request, and we need to flatten that on a vehicle proper value again. So the first value is going to be the request ID. Then we're going to tell what type of workflow is going on. So in this case, it's Android switch, which is the modern workflow that we're talking about. And then the next value is what information about the target user, the user we're switching to. So let's say I'm switching to user 11. So I'm going to pass 11 as the user, and the user flag in this case is 0. And then we also tell the information about the current state of the user. So we're going to tell what is the current user and the list of existing users. In this case, for example, I had 3 users, and the current user is user 10. So I'm going to send that information about user 10 first, then the number of existing users, and the pair of a user and flag for all these 3 users. Once user hall got this, they need to, let's say they say, okay, it's fine, you can switch that user. So they need to send us a switch user response. So they're going to send a property change event using the same request ID. And then they have to tell the type of this message is a vehicle response. And then what's the status, which is success, which value is 1. So the response would have these values 42, 3, and 1. Now let's say at that point when Android system car service receive that value, they're going to switch the user on Android, and then they will ask Activity Manager to switch the user. So if Activity Manager switched the user, it means the current user now changed. So we're going to be sending what we call this post switch request, which is the equivalent of commit. So we're going to tell how, okay, here is the post switch request for that previous request. So we're going to be using the same request ID, which was 42, and we tell this message type is 5, meaning that's the post switch. And now you can see that both the target and the current user are the same, are 11, meaning the user was successfully switched on Android. So now you can change your internal state. Similarly, if for some reason the Android switch failed, the target and current user would be different because the current user didn't change. So then the hall would know that the request failed, and that would be the equivalent of rollback. So that's the modern workflow that only happens when user switch is triggered by car user manager. But there might be cases where the user switched by Activity Manager itself. So let's say you haven't changed your APIs to use car user manager yet, or for some reason we forgot there was one specifically why there was Activity Manager. So when that happens, we still gonna communicate with user hall that the user was switched, but this is more like what I call a FYI, one-way call, meaning we're telling the hall that the user switched, but there is nothing the hall can do. Like if the hall send us a feedback saying, oh, we cannot switch that user, unfortunately there's nothing we can do because the user was already switched, so we're just going to be ignoring that request. Let's take an example of how that request would be. It would be pretty much the same as before. The only difference is going to be the type of the switch user message type would be legacy Android switch, not an Android switch. Finally, we also let the whole request user Android user to be switched. So the typical example we foresee that could happen is, let's say I'm open the car with using my wife's key fob. So we send Android system are gonna send initial user info request to Hall, and Hall will say, okay, this was open with Philippe's wife fob, so let's reply to Android ask to switch to that user. So Android starts with my wife's user. Then when I sit on my bank, when I sit on the car, there might be some camera that there's some face recognition software that recognizes me as Felipe. And now they know that, okay, I know the driver is Felipe, but the Android user is wrong. So they can ask Android to switch user. So what Hall can do in this case, they can send a proper change event with the Android switch, with the switch user and asking us to switch. So let's say an example. Next slide. So this is the same property. Like is a switch user request. The request ID now is defined by Hall, so it has to be a negative number. It doesn't matter what number it is, but it has to be negative. So car service doesn't try to correlate that with a pending request. And the type of the switch user in this case is vehicle request, so they have to say type is for. And finally, they have to tell what's the target user ID, what the user ID we're switching to. We don't need to worry about other info like flags or existing user because that's Android data that Hall doesn't know or doesn't need to know. So once the car service receives this request, it will try to switch to the user. And if it succeeds, then actually it will try to switch to the user and then it will inform Hall what happens. So if the user was switched fine, then we're gonna send Android post switch anyways. So the request ID in this case is gonna be this minus 108 or whatever ID was sent by the Hall. And then the type is Android post switch again. So it's the same post switch that we saw in the previous example. And then the target current user is 11, so meaning the user succeeded. So pretty much from the Android post switch point of view, this is the same. It doesn't matter if it was requested by the modern workflow or by car itself, but the user hall would know based on the request ID. So that's it for switch user. That's the more complicated API that we provide in user hall. Next, we have to create user and remove user. So similarly to switch user, create user is called when the Android user is created. And this is also a two-phase commit where the user has to be created on both Android and car. The difference is now because we cannot call car first or hall first because we don't know what's the user ID. We need to create the user first. Then we get the user ID, then we make this create user request, and then hall can tell us if it's okay to create or not. So if the hall said it's okay, everything is fine, the user is already created. But if it failed, then Android is going to remove the user. Remove user, it's even simpler because this is another what I call FII call. So basically, every time a user is removed on Android, we tell how, okay, this user was removed, but there is nothing you can do. Unfortunately, it would be too complicated or to roll back if the how couldn't handle that. So we decided to simplify and just put it as a one-way call. The final property you have to implement, I mean, actually, these four previous properties you would have to implement if you're supporting user hall. We have to implement all of those properties. But if you're not, or optionally, you can also add this user identification association property, which is used to associate a user with an identification mechanism. So what exactly is identification mechanism? Well, that's a way for a car to identify a user using some hardware like a fob, like a key fob. So the idea is this API, this whole property is going to be get this set, meaning that we might be asking how if the user is associated, if the current user is associated with this given types, or we could ask them to set. So the types, we're providing 5 types. One is key fob, which is the key fob. I don't know also key fob. I don't know how to explain that, but I'm pretty sure everybody knows what it is. And we're also providing these types that we call custom 1, 2, 3, 4. So let's say you have an OEM that has some new mechanism like a fingerprint on the door handle or something like that. So you could use a custom value as a form of identify the users. So that's what we call the type. And then the value is going to be either associate or disassociate, or in some cases like disassociate all users. So this is a slightly simple property, so we don't have an example here, but I will mention later, again, when we talk about the APIs that use it. We're also providing a C++ helper library. So you saw like on my previous slide, I show how the request and response works, but you have this request and response has to be converted into a vehicle property value and vice versa. So this could be a very painful and error-prone approach for OEMs to do. So instead, we're going to provide a library that does the work for you. Unfortunately, we didn't finish that library on time for the initial Android 11 release, but we have implemented that internally. So once the Android 11 is pushed to ASP, we're going to be providing some patches that backport this library to ASP. After all, this library is not something that's needed to run the Android. It's something that you can just you can patch and build your user hall on top of that. So here's an example back to our switch user response. So rather than pass this value is 4231 directly, knowing that you have to put that on that order, you just need to you create a switch user response, which is is a object defined by types of hall. Then you're going to set the request ID is the same request I get from the request. Then you can use the constants, the enum constants for message type and status. Then you call to vehicle property value that will be convert that to a vehicle property value. Finally, we also implemented the user hall on the default view hall, meaning we added these properties for on the default view hall. Now, the default view hall doesn't have any internal users, like they don't have a seat assignment or mirror. So how exactly did we implement that? Well, this is more for debugging purposes. So what we did is by default, whatever call is made, whenever car service calls user hall, the default user hall, they will return just a success or a default or whatever is the standard response. But then the developer can use ls hall to interact with the hall and change the behavior. So basically, you can tell the default user how to exactly respond to some properties. Just get back to our example of switch user. Let's say I want to explicitly tell that I want to return the type vehicle. I have to set my, sorry, let's go back here. So if you look on the bottom, we know like we need to pass this value is 4231, the request ID, the vehicle response and success. So when I call ls how, I pretty much am setting exactly those values. So I'm programming what would be the behavior of this call. And then whenever the user tries to switch user using the UI, for example, that would be the response. We also add some commands on car service where you can explicitly call how without doing anything. So I can call adb shell command car service switch user 11 dash dash how only. So the dash dash how only means we're going to be calling how and printing the response, but we're not going to switch the user. So the user would still be remaining at 10 or 12, whatever it is. If you didn't pass the dash dash how only, we will do a full user switch. So that would be useful to test that behavior as well. So that's it for user how. And the user how, we saw it has like 5 properties. And one of this property, which is the initial user info, is automatically called by the framework, by Kai service in some specific points. But the other uh, properties they're calling, they have to be triggered by some APIs. And these APIs, they're going to be provided by Car User Manager. So the idea is that Car User Manager is going to be the entry point for every operation that needs to integrate with user hall. And eventually, you will be also adding some other functionalities that could be provided by User Manager, Standard User Manager, and some other core framework classes. So if you're familiar with the Car User Manager helper, it's pretty much this kind of the same idea, but it's slightly more sophisticated. And in fact, the Car User Manager helper is still available, but we're going to be long term is going to be everything's going to be moved to Car User Manager or some other places. Also, all these APIs, most of these APIs are already used by car settings. Like car settings already using calling switch user, remove user, and uh, create user through this new API. It doesn't use the user identification association yet, but the other ones they do. So you can look on how car setting works if you want to have an example. So let's take a look on the APIs. I would say there are 3 types of APIs. One is APIs for the existing workflows, which means an alternative for the existing methods provided by user manager or activity manager, like switch user, create user, and delete user. So they have 2 differences between, or 3, between them and the core framework classes. One is that they will be talking to the user hall. The second is the results is going to be async, especially because we depend on what is returning by user hall. And third, they're going to be returning a full result, not just a primitive type. So when you call activity manager.switch users, they're going to return true or false. But in our case, we're going to be providing more information. Let's take a look on switch user. Create user and remote user is simple, so we're just going to see switch user. So the parameter is the user ID, which is the user you're switching to, and then it's going to return a user switch result. So the result is there's many codes like a status successful, status Android failure, status hall failure, status hall timeout, etc. So we're going to tell exactly why it failed, which you can get through get status. And most cases you don't care exactly why it failed, just whether it succeeded or not. So we have this success boolean that is a better approach to use. And also we provide a way for the OEM to provide an error. So if the hull failed for some reason, let's say there's some ECU components that are not ready or something, so the OEM could communicate that back through an error message. So I didn't mention that before, but the switch user response, you can pass an error message as well. You can pass something on string value, and then we would pass that back to the caller. Finally, notice that this result is async, meaning you don't get the result right away, but you get a promise to get this result in the future, which is an Android filter that stands the traditional Java filter. And you can basically, there's 2 ways you can use this result. You can block until the result is available. That's what I call sync mode. In that case, you call get. Or you can use a callback. Let's say you just want to show a pop-up when the result comes. You can use the uncompleted to use the async mode. Let's take a look at an example on how to do that using the sync mode. So I'm going to call car user manager switch user, and I will get a filter. And I'm going to call filter.get that will be blocked until the result is available. You could call get without any parameters, but that could block forever. If there was a bug in the implementation, it could block forever. there's no bug, we're perfect, but let's say just in case, I would recommend that you call with a timeout so you don't block. Then if the result is no, that means it timed out, so you can show generic error message. Otherwise, you check if the result is success. If it's okay, everything is fine. The user was just switched. Otherwise, you might want to show an error message. And let's say you are OEM, you know that if the hull failed, you could be provided specifically error message. So you can get that calling get error message. And then you check. If that's no, that means it's a generic error, like maybe Android failed or hull timeout or something. So you can show the generic error. Otherwise, you can show your custom error. In fact, that error could be just a code, and then you could use the resources from the context to get a translated message for that error. So next we have what we call user lifecycle APIs. So when Android, when a user is started or stopped, there's a lot of lifecycle events that goes through the user. Like the user is first started, then is running unlocked, is running locked, then the user is unlocked, is running locked, running unlocked, etc. The user switched, user stopped. Anyways, there's a bunch of lifecycle events that most of you might be familiar already, where you can register a broadcast listener receiver to listen to these events. So we are providing, the problem of the broadcast receivers in this case is that whenever a user is switching, there's a lot of broadcasts that are issued by the system, and the system itself is busy. So it might take you a long time, like half a second, 1 second to get those broadcasts. So we decided to provide a way to get that info quicker. So that's another example where the user switch is more critical on automotive than car, than on phone. So phone, they only provided these intents, but on automotive, we're going to be providing these callbacks. So the way it works, you just need to add a listener and remove a listener on car user manager. Remember, every time you're adding something, registering something, you should unregister when it's not used anymore. And then there's going to be this on event, which has the event itself. So you have the type of event, like if it's user starting, switching, was unlocked, stopped, etc. Then you get the user ID or user handle. That's the user being the main user, like the user that's been starting or switching to. And in the case of switch, you also get the previous user. So you will also see what was the user before the user switched. Finally, we have what I call these car-specific APIs, which for now is just the user identification association. So you have a way to get and set the user identification association. So back to our canonical example of key fob. If you want to check if the current user is associated with the key fob that opened the car, you can pass get user identification association, and then you're going to pass an array, because you could be checking for multiple types. But in this case, you're just going to pass one value, which is going to be key fob. Then you get a response. You should first check if the response was okay, because maybe the call timed out, or for some reason the user call couldn't respond. So you should always check for the success, and optionally you can check the error message as well. And then you get the values. We'll get an integer int array with the same size of the request, telling if the user was associated or not associated. Similarly, if you want to set the association, you pass an array type and an array of values. Like if you want to set key fob, you would say pass an array with key fob, and the other value array would be associate current user. So that's it for the user role and manager. Now I'm gonna handle to Yan, and she's gonna talk about some ways you can optimize boot through system user packages optimizations.
Hi everyone, my name is Yan. I'm a software engineer in the team, and today I'm introducing to you our new feature, System User Package Optimization. We inherited this mechanism from Android core framework, which provides an option to install package only for specific user types. Our goal here is to improve the system performance in terms of boot up time, memory, and storage. With this package optimization, we significantly reduce number of pre-installed packages for headless system user. While the exact amount of improvement varies from device to device, and on one test device we removed 100 packages from system user 0 and improve the performance by 800 milliseconds around there. And the second test device will remove 80 package for headless system user and improve the performance by 400 milliseconds. Now let's take a look at the workflow to use this feature. The first step is to set the configuration by overriding the system server overlay flags. Please note that these flags listed here can be combined freely. For example, in auto, the default value is 5, meaning we're enabling this feature, which is 1, and also we're adding 4, which means any packages that are not explicitly mentioned in the config file will be installed for all user types. The next step is to set up a config file to specify which package to install for the different user types. The config file has to be located in the same directory or the subdirectory of the makefile that builds the device system image. And here we're showing another example of what to include in this config file. For example, for the first package, the Bluetooth, we're going to install for both full and system users, while on the second package, the calendar, we're only installing for the full user. Additionally, we'd also like to share with you the workflow we took to identify the necessary package for system user 0. We're mostly evaluating individual package at Android by looking at the Android manifest file. And first, we're looking at the application level. So there are a couple of criteria to look at for the application level. The firstly, we'll evaluate whether the package is a singleton application or whether the application has a singleton component. If yes, then we're going to need it for the user 0. Otherwise, we'll move on to the next box, which will check whether the package has this specific attribute. After evaluating at the application level and we still cannot decide whether it is needed for the user 0, then we'll look at the individual components of the application. Now, a couple more steps to take. Lastly, we're going to verify whether our change is effective by syncing the change, rebooting the system server, and running the following few ADV shell commands and check the output. As Philippe mentioned before, we are enabling this feature for Android 10, which is Q as well. But please note also it is not fully supported, and you can take the following few steps to enable this feature. That is all that you need to get this feature started. And next, my colleague Mayank will walk you through some performance and troubleshooting. Thank you.
Thanks, Jan. Hi, everybody. My name is Mayank, and I'm going to talk about performance of different features and some troubleshooting tools. First, wallpaper service. Wallpaper service is disabled by default. It is disabled for two reasons. First, it would degrade the performance for user switch. User switch is a very common use case for Android Auto, as Felipe also mentioned, and enabling wallpaper service has some performance impact. It was seen that in some cases, it can slow user switch by 1.6 seconds. Second reason is that this feature is not yet requested by any OEMs. Still, the feature is available and you can enable the feature by changing this property, config_enable wallpaper service. Creating and switching to new user, either guest user or a regular user, is a relatively slow operation. To improve the performance for new user creation, users can be pre-created. This feature was added in Android 10. Number of pre-created users can be controlled by two system properties, number pre-created users and number pre-created guests. The advantage of user pre-creation is that when a user creation is requested and a pre-created user exists with a similar flag, the pre-created user can just be promoted to full user, and this is a much faster operation. Users are pre-created asynchronously on each boot. So whenever Android system boots up, it checks whether there exists required number of pre-created users. If there doesn't, then it would pre-create required number of users asynchronously, and it doesn't affect the boot time. Although there is no limit for number of pre-created users, they do take disk space, and it is not recommended to create a lot of them. Uh, User Switch UI is moved from user controller.java to car system UI package. Previously, user switch UI was part of user controller class, but in this release, it is moved to car system UI package to utilize the enhanced functionality. First, the lifecycle events. As Felipe mentioned, that we have added the lifecycle event. Now, user switch UI can take the advantage of those lifecycle event, and we have added a call in car user manager, set user switch UI callback. It allows OEM to set a callback that would be called before a user switch is started by car user manager. OEM can control user avatar and loading tags directly from the resource file. For more granular control, they can use this callback with lifecycle events. Currently, car system UI uses this callback with lifecycle event to control UI shown during the user switch. Events logs is an existing buffer in Logcat. In this release, we have added lots of messages in the event buffer. The reason is event buffer is more space efficient. So even your buffer size is small, it is likely to have more messages. To see the event log, you can do adb logcat minus b events, and then you can grab your event of interest. Like in this case, I'm grabbing car user hull. You will find that the events from a particular area have the same prefix. Uh, so you can easily grab them, the tracking events. More events can be found at this location, event logtag.logtags file. Next, I'll talk about a couple of tools, how we can use them for debugging, troubleshooting, and performance monitoring. First one is user switch app. This app tracks and logs the lifecycle event as Felipe mentioned by Felipe in his slides. The app exists at this location, and these are the instructions to install the app. This app can be very useful for troubleshooting and debugging during user switching. This slides represent the output of this app, logcat output and dumps output. First, the logcat output, you can see different events like starting user 11, switching from user 10 to user 11, unlocking, and so on. So in this example, I switch from from user 10 to user 11, and later on, after some time, I switch from user 11 to user 10. So you can see that different events are logged, uh, and you can see them using ADB logcat. You can also dumpsys this service using ADB shell dumpsys command, and it will give you all the events which has been received so far. There are a couple of more tools. One is Trebuchet and Atrace. Trebuchet is a Kotlin library for parsing and analyzing Android trace file generated by Atrace or systrace command. This is an open source project. Atrace file you have B and E marks. B is for beginning and E for end, and you can end which are you these B and E marks are used for calculating the duration of any tracking event. The A trace can also have the nested tracking event, so there can be B and E beginning and end of another tracing event sandwich into another tracing event. Using Trebuchet and A trace, we created an example that how these two tools can be used for troubleshooting and debugging. The example is available at tools/trebuchet, and these are the instructions to install the example. This is the output for this particular example. The goal was to know that how much time was taken in different stages during the user switch. So you can see that in the start user phase, it is taking around 360 millisecond. For switch user phase, it is taking around 237 millisecond, and so on. And in each phase, which service was the most expensive? So in this case, I displayed like top 5 most expensive services. You can use something like this to find out the bottleneck during the performance and troubleshooting.
That's it. Thank you all for coming, and have a nice day.